Welcome to the Pivots Interactive Flame Test Lab. The first part of the lab is very straightforward. Watch the video, answer 2 questions, and you need those 2 questions to unlock the section that is listed here. I've hidden the first 2 questions, so not to give away the answers. In the second section, there are 2 tasks. You need to first determine the brightest wavelengths of lines in 4 different spectra. Then you're going to be given a combination spectrum from a mixture of an unknown, and you have to identify which ions are present. Now, the good thing with the Pivot Interactives is they have these toolbars here. And when you click on the toolbar, the only tool we have available right now is a ruler. This ruler runs nanometers from 350 all the way up to 725. Each one of these divisions represents 5 nanometers. And for those who are wondering, a nanometer is 1/1 billionth of a meter, or roughly 1/10 millionth of a centimeter. The flame that you're going to analyze is for an element that's being put into a Bunsen burner. When you put that element and burn it in the Bunsen burner flame will change different colors. That by itself is insufficient. Using a diffraction grating, which is essentially a prism, we can split that Bunsen burner flame into its component colors, and then using a small slit placed in front of it, the flame and the diffraction grating, we can actually divide the light into its individual wavelength lines. Every color represents a different wavelength. This blue line right here is at, let's see, if that's 450, the next line is 455, the next line is 460. So it's between 455 and 460. We would want to record that in the data table down here. We would go to the next bright line, record its value, the next bright, the next one of these next individual bright ones. Do your best. Once you have a list of wavelengths here, this is your reference table. You do the exact same thing with the unknown and compare the wavelengths that you see when the unknown is burned.
But not yet.
And you should, based on the numbers you see, be able to go back and match it up to different elements in here. Why do we do something like this? Astronomy uses this method or variation of it to determine the properties of stars throughout the universe. From the spectrum of stars, you can determine what's in the star, how the star is moving, how fast it's moving, how old it is, how bright it is, whether there are planets orbiting that star. This is a very useful tool for astronomers, and in fact is one of the only tools astronomers have to learn the properties of stars that are billions of miles away. Good luck with the lab. Let us know if you have any questions.